So usually when we talk about this transport layer, right? So in the transport layer, we talk about process to process protocol. It is something like, again, I mean, like, so now you assume that you are running one process with the server. Okay, some Python program you are running where you do some data, and you have a browser in your PC, right? So browser, if you see that there is other kind of process which is running in the PC, right? Now, if the browser wants to talk to another host process which is running in the server, right? So that is, we call it as a process to process. It's a protocol which basically deals in the transport layer, it's like browser to browser. So the general protocols used for this process protocol is TCP or UDP. Okay. So it is also called program to program protocol. So usually when you actually like access certain IP address and all, we talk about port numbers, like port number, right? So like TCP is a connection oriented protocol. It creates a virtual connection between two TCP systems, whereas UDP uses port number to send it. Then that's the difference. So if you are using UDP, so usually you might have seen which port number you are sending. So it uses port number, whereas TCP it uses virtual connection. So TCP uses flow and error control mechanism to transport label. So I mean, in case of like UDP lower layer, but in TCP basically in the transport layer also we have, so previously we saw where was that flow control and data used to be in data layer network. So in TCP basically uses in the transport layer itself, more secure and more error control. So hence like TCP is also called connection oriented reliable transport. I mean, that protocol we had seen in the UDP, right? So I mean, this is the lower layer. But here in the upper layer itself, we have added flow control. So it's like more reliable protocol. So it adds connection oriented and reliability features to the service of the IP. Okay, so it's like TCP is kind of more reliable protocol. So we have various services in TCP, okay, process to process communication services. Here in this particular like table, most of the things you might have already seen, right? So can you tell me which are the things you have already seen? I mean, not in the syllabus.
HTTP.
One internet protocol, that is HTTP, right?
Yes, sir. A daytime.
Right,
And
data. You might have seen FTP also. Like whenever you
yes, sir.
download, for instance, whenever you want to download from Google Drive, right? So basically that is like uses file transfer. It is nothing but file transfer. Telnet.
Yes.
I mean, if you are like in industry, it will like use to monitor the status of drive. Telnet. So for each of these device, each of these services, we have particular port assigned to. Okay, so for instance, like port Telnet 23, it's taking port 23. Like for the 20th port, it is taking FTP data. 80th port, it is taking HTTP data. So okay. So I mean, these are all some of the table. I mean, like you can just go through the table. It's better if you remember because like this kind of thing they may ask to explain. When you explain it, you explain with a table. It will be more suitable.
Yes.
So a TCP is a stream-oriented protocol. When we talk about stream-oriented, like file transfer or your YouTube services, or like for instance, a better example is Zoom calling. Right? So that is actually a stream of data which is flowing, right? I mean, like calls and video streams are going from one device. So these kind of protocols, I mean, this kind of services, especially we use TCP. Whereas UDP is a process-oriented protocol. So let me consider I want to send a mail, or if I want to extract some status of like various devices. So it is like kind of process running, some processes are running. So UDP is mostly a process oriented. Okay, UDP adds its own header to each of the IP for transmission. Okay. UDP adds some header. Each message from the process is called user data gram. Okay, and eventually it becomes IP data. So on the other hand, TCP allows the sending process to deliver the data as a stream of bytes. Okay, I mean it doesn't add like header to each byte. So whenever we add header to each byte, what will happen? Our throughput reduces, right? Actually, instead of sending the actual data in that packet, we keep adding a header. But whether header is useful information and no, because it is just used to route the data, right? So as we reduce the number of headers, get more and more throughput. That's why UDP is like not suitable for your streaming data. For instance, like if we consider an example of your CCTV streaming. So if you use UDP, then you may not be able to stream the HD quality of videos. Okay. So TCP creates an environment which two process seems to connected by an imaginary tube that carries their data across the internet. So especially like let me consider your banking website or net banking website or your social media site. Once we enter the password and like the credentials, so it is going to connect each other. Screen is established. So until that connection is broken, it can continuously communicate using that link or the session link, right? That is the example, like how the stream is created. We usually call it as a session based. We create one session. Based on that, we communicate. Okay.
Yes.
So you can see here, there is a process. Process in the sense you can consider think of browser. Okay, and stream of byte will flow, and receiving process another browser or another server. So in this way, the data will be transferred. Okay.
Yes.
So sending and receiving buffers we will have because at the transmission and reception might be not be running at the same speed. Okay. So best example you can consider in your home you might have 200 Mbps internet connection. In my home, I might have just 100 Mbps internet. So now, because you have 200 Mbps of data connection, you might send like maximum bandwidth data through your bandwidth. But the data what I have to receive, I will not have that capability, right? I will have 100 Mbps. So you can see intermediately we will have some buffer, so that temporarily, like whenever when you send like huge stream of data, it is stored intermediately somewhere and will match with my speed, whichever is capable to my network, and it will send in that speed. Okay.
Yes, sir.
You can think like let's example. Like highway. In highway, huge number of data can flow seamlessly, right? I mean because it's wide and you have lane or city. As soon as it enters the city, there it is like it is narrow. I mean, the vehicles cannot enter there. So what will happen? It has to be queued somewhere, right? So that like it can pass. It will have like more time to process and enter there, right? So that is like that's how we queue it and send it. So that's where we need the buffer. So at the sending side, the buffer has three types of chamber. The white section you can see here. White section contains the white, gray, and pink are there. Right? So white section is basically holds a byte that have been sent but not yet acknowledged. So TCP keeps this byte in different buffer until it receives the acknowledgement. The colored area contains byte that has to be sent by TCP. So, however, we'll see in the upcoming slides that TCP may be able to send only part of this colored section. Okay, because at the receiver end, if you cannot receive at all, so your buffer will overflow, right? I mean, some of the links have to be discarded, right?
Yes.
See, if my bandwidth capability is 100 Mbps, you are keep on pushing 200 Mbps continuously. So anyway, I don't have capability to receive that. And if you don't have like burst of data, there is no idle window, then like you have to discard it to match my speed, correct?
Yes, sir.
So TCP offers full duplex service. What do you mean by full duplex? Initially, also in the some of the session we had seen. What do you mean by full duplex? So full duplex standing by we can receive and transmit together.
Yes.
Correct? Whereas what
Yes.
do you mean by half duplex?
Like
I can transmit, but I will wait for other request. Together it is not
yeah.
possible,
Yes.
right? What do you mean by
Yes, sir.
simplex? It is like only one direction.
Only one
There is
direction. Yes, sir.
So we spoke that the TCP is a connection-oriented protocol. When a process at a site A wants to send and receive data from another process at site B, so two TCP establish the connection between them. Data are exchanged in the both the direction. The connection is terminated. I mean, these are the three possibilities. I mean, it's like not it will not happen within a second also. So I mean, it's something like you can think of your social media accounts. You log in, will work. I mean, you'll work in that, like you watch all the things what you want to watch in that social media, then you will terminate it or log out. So that is same thing is be there in the TCP/IP protocol. Okay.
Yes, sir.
So why TCP/IP is reliable service is basically it has the acknowledgement. So this whatever we are seeing, right? These are the characteristics. Okay, so I mean, if they ask you to write the characteristics of TCP/IP, you have to write. So it is a full duplex communication, connection-oriented service. These steps you have to write. It is reliable. You should mention like why it is reliable because it has the acknowledgement. Right?
Yes.
So next is actually what are the features of the TCP/IP? So TCP has numbering system. In a sense, like we can send a huge bytes, right? Huge byte of data. So there are two fields in the TCP/IP packets, that is a sequence number and acknowledgement. So these two fields refers the byte number and not the segment number. I mean, like what byte it is. So byte number. So this byte number basically helps us to at the receiver end, like you may receive like number. Okay? So at the receiver end, it basically helps to sort it out properly. Okay. So the numbering is independent in each direction. When the TCP receives the byte of data from the processor, it stores them in the sending buffer and numbers them. So the numbering does not necessarily start from 0. Instead of TCP generates a random number between 0 to 2 power 32 minus 1 because it is a 32-bit number. Okay.
Yes.
So, but like once it starts that numbering, right, 1057, but from there onwards, it is a continuous number. You can see, like, if the number starts from 1057, then it goes up to 7056. Okay. So here they have given one example. Suppose TCP connection is transmitting a file of 5000 bytes. The first byte is numbered as 10,001. What are the sequence number for each segment if the data are sent in 5 segments? So you can see sequence number 1, 10,000 to 11,000, 11,000 to 12,000, 12 to 13, 13, 14, that way. Okay. Starts from 10,001. That's what they are. It's a straightforward analysis.
Yes, sir.
So the acknowledgement number is nothing but whatever the segment number you have sent, like the the data number you have sent, byte number you have sent. So same number you will get with the acknowledgement. So that it assures that byte has properly it received at the receiver. Okay.
Yes.
So here we have flow control. So in the data link layer also we talked about flow control. What do you mean by flow control?
Like if senders continuously sends the messages and receiver is not able to consume it.
Right. So that's the same thing, right? The flame control. When receiver is not able to, uh, I mean, able to handle that much data, somewhere we have to maintain that, right? Through buffer, right? Or maybe like some kind of discarding. So TCP/IP has that flow control mechanism. Error control, we have talked enough about error control, like CRC, FEC, correct? Various coding styles. So that basically helps us in the error control mechanism. So the TCP/IP transport layer itself is the error control mechanism. Okay.
Yes.
Congestion control. So congestion is something like see, the receiver might have the capability, and it is like already he might be having capability, but the issue is right now he might be using some other transaction. Right? So I mean it's like your again traffic example I think. Your roads are having the capability. So even though the roads are having the capability during the peak hour, congested to overwhelming data, right? So that is kind of like you have to have the mechanism to control such congestions. Okay. So you can see here the TCP segment format will have the header and data. So in the header, we'll have source port address, destination port address, sequence number, acknowledgement number, HLN. Okay, but it is not for the see. If you see here, checksum is 16-bit. HLN they have given. Yeah. So it won't be like for each byte of data. This kind of data it won't be like only in UDP. It will be for each byte of data. So this is for stream of data. Okay. See the segment contains
Yes,
of like 20 to 60 byte header followed by data from the application program. The header is 20 byte if there is no option, and up to 60 byte it contains options. So then data will be huge set of data. Okay. So source port address, it is a 16-bit field. So like from where it is initiated. Destination port address, like where it has to go. Sequence number, again we saw, right? So it is actually start from some random number. It goes up to 2 to the power 32 minus 1. Right?
yes.
Acknowledgement number, acknowledgement from the receiver. Whether he received properly or not. So we'll have header and reserved for future use. I mean, if some advancement comes with respect to TCP/IP, they will add that right in the reserved field. So you can see here control field. You have that URG acknowledgement PSH, reset, sync, and ping. So it means URG means the value of the urgent pointer field is valid. The value of the acknowledgement field is valid, whether you want acknowledgement or not. Push means push data. The connection must reset. So these are the things you will give it to the receiver side. So synchronize the sequence number during the connection, terminate the connection. This kind of control data will send to the receiver so that like he will adjust to that. I mean, like if you want to terminate the connections, send the control byte so that as soon as he receives that byte, you will terminate. Right? We are mentioning or instructing the receiver like how it has to be. So window size, the field defines the size of the window in bytes that like other party must contain. Note that like the length of this field is 16 bit, which means that maximum size of the window is 65535 bytes. This is like that much data we can push. So checksum is a 16 bit like we have seen, right? So it is basically to identify is there any error or not. So urgent pointer, so it is valid only if the urgent flag is set. It's used when the segment contains the urgent data. So if any emergency data is there, if you want to transmit. So like for instance, like video data, all others, like not urgent. But you might have some critical control information which has so that kind of critical data that has to be sent to urgent. Okay.
Yes, sir.
Basically, this TCP/IP is a three-way handshake. So, in the sense, first actually the client sends the first segment, a sync segment in which only sync flag is set. Okay, first thing he will initially he will send. So it is basically for synchronization of the sequence number. It consumes one sequence number. When the data transfer starts, the sequence number is incremented by one. Okay. So then, see, you can see first sequence number is sent, right? And you can see it started from 1200, right? Correct?
Yes, sir.
Then it sends the acknowledgement that is 1201 and his sequence number he will send 480. And then he will send sequence number 1201 and acknowledgement for this 4800 is 4801. So both the way, right, we will have acknowledgement and sequence number. I mean, like we will have response and acknowledgement. Okay, request and
Yes, sir.
acknowledgement. You can see first sync plus acknowledgement, then acknowledgement. So in TCP/IP, we have a concept of half close. So in the sense, I said like both the three-way acknowledgement mechanism, right? So that doesn't mean like always both the side connection has to be established. So any one of the link I can stop the only one link sending the data. Okay, so that we call it as half close. You can see sequence
Yes.
number, it sends the acknowledgement, but again reverse acknowledgement we didn't do. Sends the acknowledgement, reverse acknowledgement is not there. Okay.
Yes, sir.
So they have given some examples. You can just go through that, like three-way handshaking already we discussed. So basically, here, like for the flow control, we discussed like we have to control the data flow towards the receiver end, right? So for that, it uses something called sliding window protocol. That is, go back and selective repeat sliding window. So it basically, whenever there is actually like the receiver cannot handle that, right? So it might discard certain packets. I mean, certain packet might not be reached at the receiver. So then what we do, the receiver will request for the missed packet. That's why, like, go back and selective repeat. Okay, you can see here. So we will have sliding window. So, like, based on that, like, only in the sliding window we are going to set. Okay, apart from other things, right? We'll just discard it. Okay.
Yes.
We'll take directly one problem so that will be clear. So, what is the value of receiver window for host A if the receiver host A if the receiver host B has a buffer size of 5000 bytes and 1000 bytes of received and unprocessed data. So the receiver window, you can see that already that like 1000 bytes it is there, right? So 1000 bytes already it is present. You can see already 1000 bytes are received. How much buffer is there? 5000 bytes are there, correct?
Yes, sir.
Now out of 5000, you already 1000 is present, so 4000 is empty. So now receiver window, I mean window is something like how much he can receive now, right? So now it is 4000
Yes.
bytes. So now, for
Yes.
instance, like you receive this 4000 bytes, out of that 2000 bytes already you receive. So this 1000 is not consumed. So what will happen now? Your receiver window is 5000 minus 3000, 2000. He can receive only 2000. So it means actually window is nothing but how much I can receive. So it is like his capability to receive the data. How much he can receive.
Yes, sir.
Okay. So here another question. What is the size of the window for host if the value of receiver window is 3000 bytes and value of transmission window is 3500 bytes? So see, actually minimum of that it should be okay, C window and R window, because even though he has like receiver has 3000, transmission has 3500 byte to transmit, but whether receiver can handle, no, right? So then I can limit this transmission window to this 3000. Okay, so we have to choose the
Yes, sir.
minimum of C window and receiver window and transmission window. Okay.
Yes.
Next is actually error control. So error control basically it means that an application program, I mean, you know that like how we control the error, basically corrupted signal. So one way is actually checksum, right? CRC we have seen in the physical layer and data link layer. Another is acknowledgement. We send back the acknowledgement, right?
Yes.
Another is timeout. I mean, if I will have one counter, if I don't receive the acknowledgement for certain duration, then I can say there is a. So these three mechanisms usually is used in the TCP. Okay. See here, checksum we have already discussed. It is like basically we will have one CRC field which represents any error. Acknowledgement, basically receiver confirms whether there is an error or not. Correct?
Yes, sir.
Retransmission. I mean, if there is any error, then if you don't have acknowledgement, then we will retransmit. Apart from that, you can see based on timeout also, right? RTO, that is retransmission after time. If there is any timeout, right, then based on that also your packets will be retransmitted. Okay.
Yes, sir.
You can see if there is out of order segment, if you don't receive any one of the frame, then again retransmission will be requested. If the duplicate
Yes.
acknowledgement segments is received, then again retransmission will be
Yes, sir.
initiated. You can see here sequence 1201 to 1400 it is sent. For that acknowledgement 1401 is sent. Then after 5 million, I mean usually the order of operation they have mentioned. So again, acknowledgement for whatever it sent, right? 4001 5001 it sent. And for this 5001, again 5001 to 6000 it sent. Acknowledgement for 1401, right? So that will be sent. So on. I mean, this will be keep happening. Acknowledgement, sending the data, right?
Yes,
So
sir.
here, if anything lost, so there is actually out of order, right? I mean, the sequence got out of order. So when out of order happens, how to deal with that, right? So that is actually retransmission has to happen. So that is there showing actually, like this is one of the error control mechanism. Whenever there is out of, see, whenever this is lost, the continuity lost, right? I mean, sequence number acknowledgement of that continuity we had, right? That got lost. So then it is assumed that it is out of order and retransmission will be initiated.
Yes.
Okay. Next is basically congestion control and quality of service. So you can see here, whenever there is a congestion, the peak data rate, what happens? We basically control the data flow. I mean, whatever it is incoming, so we control it so that there won't be overflow. There won't be like data loss or corruption. You can see here. Basically, average data rate is this much. Maximum it can handle this. So, but in certain scenario, whenever it exceeds, you have to limit to this peak data rate. Okay, that is the maximum traffic what I can handle. So why traffic jam happens? Whenever your traffic in the road exceeds the maximum level, right, then the jam happens. So we have to limit it.
Yes, sir.
So although the peak data rate is critical value for the network, can usually be ignored. So the maximum, if the duration of the peak value is very short, then we can ignore. But whenever it for the prolonged time we are getting the peak above peak data rate, then it is like very critical for us. Okay.
Yes, sir.
You can see usual data rate is this much. Variable bit rate, so it will be keep varying. So burst is basically at some point we will send, we will not send for some duration. Again we will send. So burst rate. This kind of traffic usually it occurs. So
Yes.
I mean, you can see like if it is a streaming data, like if you are assuming your CCTV data, it's like constant data will be good. Another data you can consider like the data usage in your college. So morning time there will be peak data, then night time it may reduce because people will not be using the data in your. But in some cases, like in some bus stand, if somebody has installed one Wi-Fi router, so whenever there is a customer, there will be peak data. Apart from that, there won't be any data, right? So that kind of burst of data will be, correct?
Yes.
So congestion already we discussed whenever it exceeds. So you can see here, whenever it exceeds certain rate, then it becomes congested.
Yes.
I think like this already we discussed in the network layer also. Throughput versus load. And this also be discussed in the network layer. So this we will discuss how we can control the congestion. Okay. So
Yes.
okay. I think this meeting will end now. So I'll share you another meeting link in another 10 minutes. I mean, are you okay with another session after 10?
Yes, sir.
It's okay, right?
Yes, sir.
Okay, then I'll share another meeting link in another time.
Yes.
Because it doesn't allow you to create a new link till 10 minutes.
Yes, sir.
Okay, I'll share it.